కొన్ని నిమిషాల వరకు
Good evening, everyone. Let's start today's session. Hope I am audible. Okay. Yes, thank you, Uma. Fine. So today's session is about applications of superconductors. We will see basics of superconductors. We will look into the basics of superconductors, what is superconductivity, and mainly the applications of superconductors. See, for our examination, it's a generalistic examination. So we will not go into research of superconductors. When a conductor will become superconductor, only briefly we will see the basics, right? Then the physics part is not our interest much. They will not ask, and for us it is not required also, because it is a generalistic examination. So before going to, very few basics is required, nothing much deeper, very few basics. See, what is a conductor? A conductor is a thing which conducts electricity. See, conductor can be for heat, whether it is a conductor for heat, whether it is for electricity, like the differentiations you can make. Now we are talking in the context of electricity. Okay, a conductor or an electric conductor, mainly the conductor of electricity, it will allow, see, let us say copper wire. It's a best example of conductor. Metals, iron, all these things are good conductors of electricity. Electricity flows through them very easily. Whereas if you have a block of wood, it will not allow the conduction of electricity through it. So that's the reason when someone is getting or he is subjected to electric shock, electric wire, people will use cloth, wood in order to separate them like that. They will not use metal rod because the person who is using will also get shock because metal is a conductor. Fine. So there are many levels of conductivity. Copper is a very good conductor. Some metals, all metals are very good conductors. Some other materials, compound materials, may not be as good as conductors. Opposite of conductor for electricity is insulator. Okay, insulator which will not conduct electricity easily. Wood is such example. Okay. Water, don't get confused with water. Sir, if wood is a conductor, sometimes I'll get shock by using wood also. Why? Because on the surface of the wood, you will have moisture, water. Through water, color electricity can flow. That's the reason you may be using wet wood. It's not need not be completely wet. The chain will be there. The connectivity will be explained, will be made, because of which you may get shock while using wood also. Because on the surface of the wood, you have this water if it is wet. So like that, conductor and insulator you have. But whatever may be the conductor, here the point of contextation is, it's not that a conductor will not offer any resistance. Forget about the terms. What is resistance? Only you understand in terms of English meaning only. Resistance means to resist, to stop the free flow, something like that. Any conductor will show resistance. Resistance means a kind of obstacle for flow of this current, electricity current, which is nothing but flow of electrons, whatever, electricity, this thing. So if a metal is there, any metal, if a metal is there, okay, we connected it to a battery or electric wire, current is flowing through this conductor. Okay, it will resist. So heat will be generated. Lot of friction will be there inside because current is nothing but flow of electrons. Yes or no? All these are electrons which are flowing inside a conductor. Why copper or iron is a conductor? Why wood is not a conductor? The reason is it does not have free flowing electrons. Okay, that is the main reason. It does not have free flowing electrons. That's the reason it is not a good conductor. Whereas copper, metals, all metals have free electrons. Current, they can pass through it. So when resistance is shown, it will show resistance because all these electrons should be moved through this like water pipe of thing where lot of atoms are there. Lot of difficulty will be there in order to pass through this current. So heat will be released. Energy will be wasted. Okay. Heat will be released. Okay, so this is the concept with respect to heat energy. That's the reason every metal is not 100% efficient with respect to electricity. Lot of wastage will be there. If you are in an electrical distribution company or in any company, there are many losses. Electrical company, the electricity distribution from generation side to our homes, lot of heat loss is there. All are conductors only, but they are associated with heat loss. Okay, so that's the reason we are now going for the concept of superconductors. We are going for the concept of superconductors. These superconductors are special conductors where they will not show this resistance. So the heat loss, electricity stabilization will be much more efficient. in superconductors. So we are trying to build those materials which can act like superconductors. Okay, technology is there through which we are trying to make such materials, different combinations we are using to create superconductors. So the purpose of superconductivity is, unlike a normal metals which we are using, these superconductors, complex compounds, metallic, non-metallic, oxides, many type of combinations are there. When they are used, they will not generate such heat loss. Highly efficient you will have. With just one battery, you can run. Maybe a small battery may be required to run an electric car. Because now all the conductors, all the metals involved in the battery, all these things, they require huge flow of current because of this resistance offered by every metal. In superconductors, this resistance will be as much minimum as possible. In fact, near to zero. Zero resistance. Okay, no loss of flow of current. That is the purpose. So understood the concept of superconductor? No free electrons, actually. That is the best way to tell, Viresh. Any doubt on what is a conductor and what is a superconductor? Shall we go ahead? Anyone has any doubt? Okay, looks like you understood. Okay, fine. Now we will see. So superconductivity, simply put, in very simple terms, it means there will be no resistance or almost zero resistance in the material with respect to flow of current. Okay, that is the purpose of superconductivity. Conductor, but superconductor. That is the things. Now, when we are calling this superconductivity, the conductivity is referring to electrical conductivity, obviously, because insulating is there, heat resistance thing is there. We are not talking about heat or any other insulating material. We are talking about electrical conductivity. Fine. Now these things. Now there is a general property. This is a general property which you have to understand. What is this general property is? If there is a material, let us take iron only, copper or iron or anything, or any material, in fact, any oxide material, any material you have, this is the material. So if you decrease the temperature, so temperature means, right, body temperature. See, I'm trying to make it as simple as possible. There is no concept of physics or chemistry here. So just a basic principle we have to understand. If you decrease the temperature, the resistance will decrease. Okay. And the same thing reverse also. If you increase the temperature of this metal means surrounding atmosphere, whatever, everything. Okay, where it is kept in refrigerator kind of thing. Surrounding temperature will affect this temperature itself. So that is the purpose. If you increase the temperature of the block, if you increase the temperature of this anything, whether it is iron or oxide metal or anything, resistance will generally increase. Okay. So if you want superconductivity, whether generally it is obtained at higher temperatures or lower temperatures? Higher temperatures or lower temperatures? Right answer? Lower temperatures. Okay, only one or two are answering. Because resistance will be, now, sab log. Fine. So we get superconductivity. Generally, we get superconductivity at lower temperatures. Okay, but the practical difficulty is it's very costly, or it's very difficult to maintain these lower temperatures. That is the challenge we have. It's very difficult to maintain a lower temperature. Suppose room temperature is 27 degrees centigrade. Can you maintain minus 13 degrees centigrade continuously? Even now, even iron, understand, superconductivity is not only for few metals. No, it is only for few. No, this is absolutely wrong. Even iron also can become superconductor, but at very low temperatures, -55, something like that. Minus chale jayega ye. Okay, at very low temperatures. Not only iron, just I gave a random example here. The meaning of this thing is all these things, most of these things, most of the conductors, metals, all these things can be converted into superconductors at very lower temperatures. Then why we are not using those superconductors, sir? Superconductivity is there in iron, in copper, all are there. But the problem is they are at very low temperatures. It's very difficult to maintain that lower temperatures. Okay, so that is the thing. Anyway, we have developed applications. We have designed the systems which are still working at lower temperatures. I asked the previous question. Someone was asking about when we will have superconductor, the resistance will be decreased if you decrease the temperature. So superconductors generally are available at lower temperature. That was the question I asked. One of your friend was asking. Yeah. So that's the problem. Coming back to our original concept, lower temperatures maintenance is difficult. We have many advantages with respect to superconductors. Resistance is low, not low, almost zero. So if you establish a current in it, only one battery connection is enough. The current will be running continuously because there is no heat loss now. So for a long time it will run. So imagine how much energy can be generated if superconductors are available. They are available now, but very at low temperature. Maintaining that low temperature is very difficult. That is the thing we start. So don't worry about this statement. I'll explain this statement here. What does it mean is, if you see, yeah, this is the meaning of the same statement I'm explaining here. This is the resistance. Forget about the technical things. Temperature is there. If temperature is decreasing, resistance will decrease. They have drawn an inclined path like this. Imagine, actually it is decreasing. Suddenly, after a critical temperature, when you go below very low temperature, generally you go it. This is not 0 degrees. Don't understand that this is not 0 degrees, 0 Kelvin. It's very low temperature actually, -273 degrees centigrade. See, look at the figure, -273 degrees centigrade. Water is cold at 0 degrees centigrade, ice. Okay, we are going -273 degrees centigrade. In Russia, the temperatures will be -40 degrees centigrades in winter, cold regions. At the max, you'll have -48. Okay, I am going where? -273. So just before that, a few temperatures, always every metal will convert into the resistance becomes 0. That is this figure, meaning of this figure. Okay, so every metal will have that property. Okay, so that is what is the meaning of this perspective here. So in such superconductor, if electric current is passed through the loop of a superconductor, the current will sustain indefinitely because no resistance. That's the reason we are calling it superconductor. Only one battery you can purchase for your mobile phone. Forever one battery. If the mobile phone is made up of superconductors. Like that. One charging. You will charge once in your birthday. On birthday, you have to charge your mobile phone. That's it. If suppose we have superconductors, but not like that, still that is not reached. Okay. So that is the purpose of this. Still now, there are many applications of superconductors. Many hundreds of materials are said to be superconducting at low temperatures. Even 27 metals are there, which are superconductors at low temperatures. Now they put more pressure, leave all these technicalities. If you put high pressure also on the metals, even hydrogen gas, which is not the conductor of electricity, if you put very high pressure, in high pressure, what will happen? You will compress it, and it will, the properties of the hydrogen will change. Very high pressure. In such high pressure conditions, even hydrogen can be converted into a superconductor. Okay, low temperature and high pressure conditions. Okay, so many chemical elements are turned into superconductors at low temperatures and high pressures. So if a question is asked, which of the following are, observe the question, I'll put it here itself. Yeah. Which of the following are generally suitable conditions for superconductivity? Okay. If such question is asked, I am giving the option: low temperature, high temperature, high pressure, low pressure. Yeah. More than one answer is possible. Tell the answer. Low temperature and high pressure. A and C. A and C is the answer. Okay. Like that it will be there. Fine. Yeah. So this is the main thing. That's just the basics. Many examples are there like that. Even uranium, which is radioactive, that also can be converted into superconductivity. Low temperatures. Many materials can be converted into superconductors. So they are using many different chemicals, different oxides they are using, and they have developed a superconductor application. This is important. This is the most important part. Rest of things are gone. So if a question is given, which of the following, of course, basics are required. Which of the following are the applications of superconductors means that is the ABC. This is the most important thing. So good memory, high storage memory devices can be designed using superconductors. Undersea communication cables, our internet speeds will be very high on this if we design such cables. Submarine detection, because weak signals also the superconductor can detect. So these are the applications of superconductors. One by one we'll see. Presently now also you will have nuclear magnetic resonance. This is very chemical. So it's a method of analyzing the compounds. What is there in complex chemical compounds? NMR is a spectroscopy, resonance, and all those things. They will use this technique to study different materials. Okay, a best way to tell this thing is MRI also. Magnetic resonance imaging. You know MRI scans in the hospitals. Okay, a big machine will be there. They're surrounding it like this. Big machine will be there. Under it, bed will be there. Okay, the person will go there. It will give big sounds. It will give. Here, the person lying down. Okay, and all scan will be done. So this all things in MRI scans, they have very strong magnets. They have those strong magnets are made up of superconducting materials. That's the reason they are very costly. They cost lakhs and crores of rupees. Okay, so because of that only very high energy generated and scans can be done. Okay, so that's the reason MRI scans, whether they are safe or not, also is a debate. As of now, scientists are saying that they are safe, but so much high energy exposition is dangerous. The same debate is there with respect to X-rays also, even mobile also. Okay, so excessive use, it's not about once or twice. Excessive use is dangerous. Right? So we are using them in it. The present other application is in magnetic levitation. What is magnetic levitation? See, train track is there. Even the wheels, the train, even the wheels also, a lot of friction is there. So a lot of energy is required to run the train on the tracks. Whereas in magnetic levitation, there will be magnets here, supermagnet. The supermagnets are created using superconductors. Okay, there will be a small levitation means uplift. The train will float. It's not that, don't think that it is a Balakrishna movie or some movie where it is floating. No. Okay, there will be a small gap, less than maybe 1/10 of a centimeter or 1 centimeter, not more than that, even less than 1 centimeter only. Okay, it will levitate. Okay, and the train will go very fast. That is the magnetic levitation. High speed trains, 400 kilometers per hour, 500 kilometers per hour. If it is 5 kilometers per hour, it means imagine you will reach Delhi around 1600, 1800 kilometers in 3-4 hours. Now it takes 24 hours for sometimes. If it is Rajdhani, it is taking 18 hours. If you have magnetic levitation, you will reach Delhi from Hyderabad or Bangalore in 4 to 5 hours max. Okay, so that is the application of superconductors. Then you have future applications also with respect to, right? With respect to conductors, you will have, they can be used with respect to generating new or manufacturing motors. Wherever conductors are used, there superconductors can replace generators, devices for measuring electrical instruments, magnetic instruments, even radiation measuring instruments also. Varieties of things can be developed using superconductors. Okay, so these are the future possible applications which we have. Okay, high performance smart grid. What is a smart grid? See, smart grid is a next, our present grid is only one directional. Okay, directional means from generating stations, okay, distribution stations, then various substations, finally reaching home. If the home is generating electricity, using solar panels or using wind or using generator, if the home is generating electricity, can you sell it back? No. This bidirectional, this direction is not there. Smart grid has such feature. It is bidirectional. Both it will supply, it will sell. And it is employs, it can employ superconducting materials. Okay. So development of that's the reason high performance smart grid, electric power transmission, magnetic refrigerators also. Okay, temperatures will be reduced very easily. Lot of energy saving can be done with these superconductors. Very interesting development is why this we have to focus is lot of applications. There will be plethora of applications if you have superconductors at room temperature. That is a challenge in which the scientists are struggling. See, all these applications which we saw, are there even today. They are trying to take it with a lot of difficulty. They are trying to make these applications. Okay, but if you have superconductivity at room temperature, if you are able to design superconductors at normal room temperatures, even less than room temperatures also, a minor, it's with small variation, the applications will be, there is no end to the applications of superconductors. Okay, so that is a very interesting area which is growing the science. So these are the probable applications which you have in various fields: energy, cables, generators, transformers, fusion, defense, motors, transportation, maglev, molars, industrial applications, induction heaters, generators, medical, MRI, particle therapy, the cancer treatment and all those things, science and research, accelerators, scattering experiments, variety of things, high frequency magnets, varieties of things you have. So all these are the probable applications of superconductors. Okay, they have built devices like this, motors like this, all these things are being. Look at the MRI scanning machine. Okay, this much big box is there. They will try to maintain low temperature and superconductivity. All these applications will be expanded exponentially if you have superconductors at normal room temperatures. There will be explosion. These are general applications which are already there. But if you have superconductor at room temperature, till now it is not there. They are trying to make some experiments. Only experimental results are there. The way in which we are studying optical fibers, superconductors. See, fiber optics is different, where light is used. One of your friend is asking, is fiber optics related to superconductors? Because optics uses, it's a kind of refraction, total internal reflection, that is different concept altogether. Using superconductor, that's what, na? Electromagnetism using superconductor. In MRI machine, the magnet is generated by electric current only through a superconductor. Okay, for generation of electric field also through superconductors. That is anyway there. Okay, so these are the various applications. The main theme is this. Some experiments are being done at Indian Institute of Science and various other areas of the world. Room temperature superconductivity. Room temperature superconductivity, they were able to maintain it under high pressure. Very high pressure they were able to do. So atmospheric pressure is one, see, general 1 atmospheric pressure. It will be much more higher than that pressure. So that is the problem. Either you have low temperatures or you should have high pressure. If they were increasing the temperature, this low temperature, they are going it to room temperature, the pressure becomes very, very high. So still they are trying to find. So room temperature conductivity applications will be enormous. Okay. So that is the very interesting area which can be a focus area in the next few decades. Okay, so that's it. Any doubts you would like to ask? Anything else? So tomorrow would be the final open session as we discussed yesterday. From Monday, we will start the actual sessions, the details of the course and all these things. Mostly it would be 8 p.m. the timings, because NCERT course also is going to start. That is the reason. So let's hope. The main things with respect to courses, weekly tests will be there. Okay, answer writing practice also included, and weekly doubt clearance session also we will have, because this may be sometimes technical subject, science and technology. So one day we will allocate for open doubts clearing session also. Okay, so these are the things which we are yesterday, what topics we are going to cover in the session also I discussed yesterday. That poster also will be it's already there in the Telegram group. Okay, so tomorrow we'll conclude these open sessions, and Monday the actual course will start. Okay, fine. If there is no resistance, yes, perfect zero resistance is not possible. The electricity will not rise. See, in order to create more, the question is, one of your friends is asking, if there is resistance from the superconductor, the appliances or motors, they will destroy, they'll get annoyed. No, the more current, more you keep, the more current will come. Okay, the current will not degrade very easily. That is the only thing. Okay. Why every day you are asking overview, Satyanarayana? We saw, let's have an overview. There's nothing difficult here actually, but let's see what we saw here. We will remove it, because I think yesterday also you asked the same. What did we see? Very quickly, if you see, what did we see? What is a conductor? We saw what is a conductor. Okay, what is an insulator? Why some are conductors? Why some are insulators? Okay, what is this concept of resistance? Because of this resistance, lot of energy is wasted. Okay, that's the reason we want to build superconductors, so that this energy wastage will be limited. Okay, fine. No resistance, all these things. We are talking superconductivity. Then we discussed about relationship between temperature and resistance. This relation, a kind of direct relationship you have. If this decreases, resistance decreases. If temperature increases, resistance increases. So we have superconductors at low temperatures for many materials. But to me, there's a lot of difficulty with maintaining lower temperature. Okay, that's what we saw. Then we saw the relationship between low temperature, pressure, and superconductivity. We saw this. After a certain thing, it's not that there is a constant decline. This is not the case. Suddenly, temperature increases, then after crossing a certain limit, that this will drop down 0. Okay, so that is a property of materials. Why this is happening? No. Why this kind of sudden drop is there? No. Go and do PhD in physics, not for our GS examinations. Okay, so we saw various applications. Future applications also we saw. Then some of the applications which are there in the existing superconductors only, we noted a point that these applications will be drastically improved if we have superconductivity at room temperature. That's it. Okay. Done, na? So happy, Satyanarayana? Your friend, one of your friend is asking other class from 7 to 9, but morning many sessions are happening, so there has to be recordings are there. Anyway, in open session timings, you can discuss doubts with me. Fine. Well, the recordings will be, I believe. So that's a choice we have to take. Okay, fine. Tomorrow we'll meet and hopefully later also. Chalo, bye. Okay, bye-bye. Semiconductors are in between conductors and insulators. That is different properties you have. Okay, one of your friend is asking, see, conductivity, the free flow of electrons. In insulator, there is no free flow of electrons. If not, no, very less flow of electrons. Conductors, there's a huge flow of electrons. Semiconductors are in between. Okay, we dope them, we use them in actually mobile phones, electronics, or these laptop computers. All was possible because of semiconductors. They act as a switch. Okay, so they generally are not used for conducting electricity in this distribution of wires and all those things, motors. Their properties is different, mostly in the electronic sector and all those things. Fine. Okay, so that is the basic difference, Mr. PK. Chalo, bye.